Good morning. My name is Asha. I am working as an assistant professor at S.A.E. Engineering College. Today I am going to explain the topic about data link layer from computer network subject. First, let us see about the introduction to data link layer. There are 7 layers in OSI reference model, and this data link layer is present next to the physical layer in the OSI reference model. This data link layer is responsible for transmission of packets from network layer to the physical layer in form of frames. During transmission of frames, this data link layer is used to encode the data at the sender side and decodes them again at the receiver side for the secure transmission of packets between the network layer and the physical layer. This is a block diagram showing the functions of data link layer. The packets from the network layer are received at the data link layer. At data link layer, these packets are divided into frames and sent them back to the physical layer. Next, let us discuss about the sublayers present in data link layer. There are 2 sublayers present in the data link layer. They are logical link control sublayer and the media access control sublayer. Let us discuss each and every sublayers in detail. First, let us discuss about the logical link control sublayer. This sublayer is responsible for transmission of packets from the network layer to the physical layer in form of frames. During transmission of frames, there will be possibility for an error to occur. So in such cases, this layer is responsible for displaying the error message to the user. In addition, it also sends acknowledgement to the user. If the data is transmitted successfully at the receiver side, it sends positive acknowledgement to the user, else it sends a negative acknowledgement to the user. So the overall responsibility of this logical link control sublayer is a secure transmission of packets between the layers, displaying the error message and the acknowledgement to the user. Next, we can see about the media access control sublayer. This sublayer is responsible for managing the interaction between the devices, providing the physical addresses to the frames, and managing the flow of data through the channels. Next, let us discuss about the functions of the data link layer. There are 5 functions of the data link layer. They are framing, addressing, access control, error control, and flow control. Let us discuss each and every functions of the data link layer in detail. First, let us discuss about the framing function. Framing is nothing but the concept of transferring the packets from the network layer to the physical layer in form of frames. At the sender side, the network layer sends the packets to the data link layer, and this data link layer divides the packets into frames and sends each frames bit by bit to the physical layer. At the receiver end, this data link layer, it receives the bit by bit and organizes them into frames and sends back to the network layer present at the receiver end as a packet. This is a block diagram showing the functions of the framing. So as I said earlier, at the sending machine, the packets which are present at the network layer are sent into the data link layer. At the data link layer, the packets are divided into frames and it is sent to the physical layer which is present at the sender side. At the receiver side, this data link layer, it gets bits from the packet, bits from the physical layer, and it organizes them into frames and sends back to the receiver on the side network layer as packets. Next, let us discuss about the parts of a frame. So each frame, it consists of 4 parts such as flag field, header field, payload field, and the trailer field. Flag field, it is used to indicate the start and the end of a frame. Header field, it contains the source address and the destination address. It is essential to add the source address and the destination address because it has to know from where the packets has to be picked and to where the packet has to be sent. Payload field, it consists of the original data that has been transmitted between the sender and the receiver. And the last one is the trailer field. During transmission, as I said earlier, there is possibility for an error to occur. So in such cases, it has to notify about the error. For that purpose, we are using the trailer bits. So this trailer bit is used to indicate the presence of errors during the transmission of the data. Next, these are some of the methods that are used for framing. They are character count, flag byte with character stuffing, starting and ending flags with bit stuffing. Let us discuss each and every method in detail. First, moving on to the character count. This method, it is used to determine the number of characters present in each and every frame. For example, let us consider the figure A. So this is the first frame. It consists of a character count as 5. So first frame, it consists of the number of bytes 5. 1, 2, 3, 4, 5, including the character byte 5. So if you take the second frame, here the character count is 5. So this character count 5, it indicates the number of bytes in the second frame, which is nothing but 5. 1, 2, 3, 4, including this character count 5, it becomes the 5 bits are there in frame 2. Moving on to the frame 3, the character count is 8. So there must be 8 bytes in the second frame. 1, 2, 3, 4, 5, 6, 7, including the character count, it becomes 8 and so on. So this is the original message at the sender side. At the receiver side, we could see that at the frame 1, there are 5 bytes, 1, 2, 3, 4, and including the character count, it becomes 5. But on moving to the second frame, we could see that there are 7 character count in the receiver side, whereas in the sender side, there is only 5 character count. So this includes that there is an error during the transmission of data. The second method is flag byte with character stuffing. So this technique, it is used to add some special characters such as escape before the special patterns such as escape, flag, etc. For example, let us consider the original characters A, flag, B. In this original character, flag is the special pattern. So before this flag, they have to enter a special character called escape. So after stuffing, the original character becomes A, escape, flag, B. Second, original character is A, escape, B. Again, in this original character, escape is a special pattern. So before this escape, we have to include a special character called escape. So after stuffing, it becomes A, escape, escape, B. Let us consider the third original character, which is nothing but A, escape, flag, B. So here in this third original character, there are 2 special patterns, which are escape and flag. So we have to include escape character before this escape special pattern and one more escape character before this flag escape pattern. So after stuffing, it becomes A, escape, 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 flag, B. The fourth original character is A, escape, escape, B. So between A and B, there are 2 special patterns, which are escape and escape. So before these 2 special patterns, we need to include a special character called escape. Hence it becomes A, escape, 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 and B. Next, let us move on to bit stuffing. So in this technique, we are going to add zeros after 5 consecutive ones. For example, this is the original message which is present at the sender side. So after stuffing, it becomes, so here we could see that there are continuous 5 ones. 1, 2, 3, 4, 5. So after this 5, we have to insert one more on a 0. So this is called as a bit stuffing. So after the stuffed bits, this 5 consecutive one becomes 1, 1, 1, 1, 0, 1, 1, 1, 1, 1. So this is called as a bit stuffing. The next function is addressing. So it is used to provide source and destination address to the frames. As I said earlier, source address and destination address are very essential in order to know from where the packets are picked and to where the packets has to be sent. The third one is the flow control. So this function, it is used to synchronize the transmission speed between the sender and the receiver machine. There are 2 protocols that are used at the flow control. They are the stop and wait protocol, sliding window protocol. In stop and wait protocol, each frames are sent one at a time. So when the sender sends the frame, it has to wait till it receives the acknowledgement from the receiver that the frame has been received successfully. So once the sender receives the acknowledgement, it sends the next frame. Whereas in sliding window protocol, it sends several frames at a time, which means that the sender does not wait for any acknowledgement from the receiver end. The next function is the access control. So it is used to determine which device is having the control over the channel. As I said earlier, the data has to be transmitted from the sender to the receiver through a channel or a device. So we need to know which device is having the control over the data. Next one is the error control. During transmission of our data, there is possibility of an error to occur. So in frames, we will be using the trailer bits to identify the error that occurred during the transmission of data. So this error can be controlled using the three ways. They are error detection, acknowledgement and retransmission. So in error detection method, the error detection bit will be added at the end of the frame in order to identify the errors that occurred during the transmission of frames. Acknowledgement. So once a frame has been transferred from the sender to the receiver once he receives another message, he has to send acknowledgement to the user or the sender mentioning that the frame has received successfully. So if the receiver sends negative acknowledgement to the sender, the user has to or the sender has to again retransmit another frames to the receiver. And this is what the third retransmission. If the data frame does not reach the receiver successfully, the user or the sender has to resend the data frames once again. Then there are types of error. There are three types of error. They are single bit error, multiple bit error and burst error. So single bit error, if only one bit in the transmitted data is getting affected, then it is known as a single bit error. This is a diagram showing the single bit error. So this is the original message. In the received message, during transmission, we could see that instead of 0, 1 has been added at the transmitted data. So it comes under the single bit error. The next one is the multiple bit error. If more than one bit is getting affected, then it comes under the multiple bit error. The third one is the burst error. Then there are, when error occurs continuously or in sequence, then it comes under the burst error. So there are some issues that may occur in data link layer. They are service provided to the network layer, framing, error control and flow control. So these issues has to be addressed in the data link layer. Moving on to the gate questions. First question, which of the following task is not done by the data link layer? And the options are framing, error control, flow control, channel coding. So the option is D, because data link layer, it does the function of framing, error control and flow control, but it does not does the function of channel coding. So the option is D. Question number 2, error detection at the data link layer is achieved by bit stuffing, humming codes, cyclic redundancy codes, equalization, and the option is cyclic redundancy code, which is nothing but the error detection code which is present at the end of the frame. Question number 3, consider the following two statements. Statement 1, destination MAC address of an ARP reply is a broadcast address. Statement 2, destination MAC address of an ARP request is a broadcast address. Which one of the following is correct? Both S1 and S2 are true. S1 is true and S2 is false. S1 is false and S2 is true. Both S1 and S2 are true. And the option is C, which is statement 1 is false and statement 2 is true. Because destination MAC address, it consists of an ARP request which is a broadcast address, whereas ARP reply is a unicast address. Question 4, an information frame is used to dash in HDLC and the options are send data, set up a link circuit, acknowledge data frames, perform error control, and the option is perform error control, because this HDLC it is used to perform the error control. Question number 5, which sublayer of the data link layer performs data link functions that depend upon the type of medium? The options are logical link control sublayer, media access control sublayer, network interface control sublayer, and option D is error control sublayer, and the answer is media access control sublayer, because this media access control sublayer it is responsible for managing the interaction between the devices, providing the physical address to the devices and managing the flow of data between the devices. Question number 6. The following data fragments occurs in the middle of a data stream for which the byte stuffing algorithms described in the text is used, and the text is A, B, escape, C, escape, flag, flag, D. What is the output after stuffing? Option A, B, escape, C, escape, flag, flag, D. B, option A, B, escape, escape, C, escape, escape, flag, flag, D. C, option A, B, escape, escape, C, escape, 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 flag, escape, flag, D. D, option A, B, escape, C, escape, escape, flag, escape, flag, D. And option is C, because A, B are the messages. Escape is a special pattern, so we have to include a special character called escape. So it becomes A, B, escape, escape, C. Again, escape is a special pattern, so before escape we need to include escape special character. So it becomes A, B, escape, escape, C, escape, escape, flag. Again, this flag is a special pattern before which we have to include a special character. So it becomes A, B, escape, escape, C, escape, 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 flag. Again, this flag is a special pattern before which we have to include a special character called escape. So the message becomes A, B, escape, escape, C, escape, 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 flag, D. Thank you.